Hello. PreCalc. 1112. Oops. 112. 17. All right. Today, let me see what board, if that showed up on the board. I don't see it. Where did it go? Alright, let me try something. There it is. The board wasn't showing everything. Alright, I'll try to say in the screen. 112:17. Today we're going to prepare for the law of sines on our test. And our test will be a take-home test. We'll give you about a week to do it. And the law of sines will be on it because it hasn't been on any of our tests. It kind of slipped through. So here's how the law of sines works. A over sine A is B over sine B equals C over sine C. And our first and only example, A is 60, little a is 9, and C is 10. All right, turn off the camera and see if you can draw that triangle and use the law of sine to solve it. Find all 6 parts. I've given you 3. You use the law of sines to find the other 3. First of all, draw the triangle. All right, did you get it? Here is A, B, and C. It's a non-right triangle. It's not a right triangle. If it was right, we'd use the Pythagorean theorem and be done. But that doesn't work when there's no right angles. So A across from big A is 9, and little c across from big C is 10. So I have to come up with this part, which is little b, this angle, which is big B, and this angle, which is big C. The law of sines is used when we know a pair. That is a side and the angle opposite, which in this case we do. We know this pair right here. So I'm going to include that pair in my proportion. So I'm going to use this equals, I'll use C because I have some information about C. So 9 over sine of 60 is my A over sine A. Now I'm going to jump to C, which is 10 over sine of C. So this proportion has one unknown on it. So you want to get a proportion which has one unknown. We multiply both sides by sine C. So it disappears from this denominator and appears in this numerator. And we multiply at the same time both sides by sine 60. And I'm going to get sine of C equals 10 sine 60 divided by 9. When I did that, I put that on the calculator to see if I'm still in the screen. Okay. Yes, I am. Sine C will come up to be 0.96. And I do a sine inverse of 0.96 to see what angle has 0.96 as its sine, and that will be my answer. It came out to be 74 degrees. All right, if that went off the screen, I'm sorry, but you could hear me. Sine inverse of 0.96 is 74. So I'm going to put that answer up here. The only thing is, the law of sines is somewhat limited because when you have this step in the law of sines, and I'll put it up here, this is a warning. When you have sine of some angle, in this case C equals 0.96, when you have that, I have to give you a warning because the law of sines is somewhat limited. It's sort of, it can only get the right answer under certain conditions because sine of C, the inverse sine of 0.96 did give me 74 degrees. But I know, because I know about these things, there's another angle. that has a answer to this problem, and the calculator doesn't know it. And that angle is in the second quadrant, where the angle is 180 minus 74. So you have to look for a second case. And in this one, it's not too hard to investigate, so I'll go ahead and do that. This one was set in the problem, this was set in the problem, and this was set in the problem. These I calculated. So let's say that I keep the ones that I set in the problem true. So what I end up doing, if I can't change this angle, but I can change this one, I can change this one, and I cannot change this side. So this is set in stone, this is set in stone, this is set in stone. So I could swing this. I know somebody, was it you, Andrew, didn't like the word swing, but I can rotate this angle, this side 9, keep it as 9, and I'm wondering if it'll fit over here and create a whole second case. So I have to check for that every time. So the way I check for it, let's go ahead and finish, let's see what B would be, because we had 74 is 74 in this angle, 60 on this one. So if I subtract the sum of 60 and 74 from 180, that'll give me that angle, and I got 46 for that. That's not set in stone, either is this. So the ones that are circled are set in stone. I'm going to swing the 9, side 9, which I can't change its length. It was given in the problem. I'm going to swing it over here and create another triangle, this little one. Now, this angle would be 46, because this is an isosceles triangle, the base angles are alike, and the angle on the other side, inside our new small triangle, would be 180 minus 46. So I get 134. So 134 is going to be, we got to check and see if that's a possibility. So we know 60 is set in stone. The 134 plus 60 gives us 194. There's no angle, no triangle that can have this 194 degrees to work with, because we need a third angle, and we've already used up 194 by 134 and 60. So therefore there's no possible second triangle. But you have to check every time to see. So this is only one answer, and I'll put the answer up clearly here. We have 60 degrees was given, 9 and 10, and we calculated 74 and 46. Did we do B yet? Little b? Little b. No, we didn't. All right, let me make some room and I'll do little b. So we have one more spot to calculate. Using the law of sines again, I do A over sine A, 9 over sine 60, equals little b over sine of b. I now know b is 46. Multiply both sides by 46, sine of 46, equals b. So I calculated 9 times the sine of 46, 9 times the sine of 46 divided by the sine of 60. I don't have that, so let me calculate it real quick, as you do as well. So 9 times the sine of 46 divided by sine of 60. Alright, I got 7.5. 7.5 is my answer for side B. 7.5. Alright, so this is the whole answer to the triangle. Let me see how much of that showed up. It's hard to tell from my vantage point. Alright, it looks pretty good. Alright, so the warning is, when you get a statement like this in the law of sines, you have to check for 2 solutions, because that's the way it is. Alright, let's do the law of cosine.